go ahead and get started. Today our speaker is Rafi Kurlansek, one of our engineers with a lot of expertise in open source. And specifically our webinar today, we are going to be discussing and showing you how to create some pipelines with Apache Spark and Kafka. Rafi?
Okay, thank you, Anna. Hello, everyone. My name is Rafi Kurlansek, and on behalf of IBM, I would like to thank you for joining us today. As an open source solutions engineer in IBM Analytics, my job is to help businesses and the larger analytics community understand the value of open source. So today, we're going to learn about how to build a generalized streaming pipeline with Apache Spark and Kafka. We'll cover some different use cases for streaming, the architecture. We'll talk a little bit about IBM's commitment to Spark, as well as a deep dive into the Spark API itself. So without any further ado, let's take a look at today's agenda. Today's webinar is composed of 5 segments. First, I'll talk about the motivation behind creating this demo in the first place. Second, we'll look at the data we'll be working with and define the question that we're trying to answer. Third, I'll provide an overview of the solution architecture and how it could be generalized. Next, we'll fire up a number of terminals and launch the services and scripts required to get a streaming pipeline up and running. Part of this demo will be a walkthrough of the Spark program I wrote, where I'll be highlighting key features of the Spark API and sharing some tips that I learned while working on the project. Once the demo portion is complete, we'll conclude by reviewing what we've done, talking about IBM's commitment to Spark and how you can begin using Spark today in the cloud for free. Okay, so what was my motivation for doing this project? Well, streaming is a technology that's increasingly ubiquitous in our lives. As more and more companies develop apps and products with digital components to them, there's a tremendous amount of data that's being created. And companies want to A, collect that data, and B, interact with it as close to real time as possible. Furthermore, to be competitive or innovative in the market, incorporating machine learning is increasingly becoming a requirement for business. So due to all these factors, I wanted to build a demo that showed how Spark can be used to solve these problems in multiple industries. So what goals are we setting out to accomplish here? There are really 4 of them. Like I said, it's to showcase the power and flexibility of the Spark API. I would like to join data at rest with data in motion, meaning data that's residing in a database or a flat file and the actual streaming data coming in. I'd also like to incorporate machine learning into my workflow. And then I have to store my predictions on somewhere. So we're going to write those out to an external database. Okay, with that said, now we know what our goals are and our motivation is. Let's take a look at our data source and the question that we're going to be asking. So Wikipedia publishes a stream of edits that are made to its articles. And one of the fields in that stream is a binary classification called isBotEdit. So that when I saw this, it caught my eye, and I wondered if we used all of the other data published in the edit stream, would it be possible to predict whether an edit is made by a bot or not? And the reason why this appealed to me is because binary classification problems exist in different industries. For example, in healthcare, you may want to stream data from machines in the intensive care unit, scoring the data as it comes in the hopes that you can predict when a patient goes into sepsis or some other dangerous state. Or perhaps you work in manufacturing and you want to classify incoming sensor data from the factory floor. Are your machines working properly? Are defective products being produced? Is a machine approaching the need for repair? All of these problems can be thought of as classification problems. So keep in mind the generalized pipeline that we create here with the Wikipedia data, and remember that it can be applied to different data sources. Okay, so let's look at our data from Wikipedia. It's published in JSON, and if we were to take that JSON and turn it into a table or a data frame, that's what you would see below. Some of the fields that are included here are byte differential, which is the first one you see on the left, and that is the byte change to the article, whether it's positive or negative. There's also a summary of the edit, the title of the article, and the user responsible for the edit. Now, I'd just like to note that in our JSON example here, the user Karst thought that it was important to set the record straight about Marilyn Manson. He is not a rapper of note. And no, I did not make this up. This is a real edit that was published in the stream. So I'm glad we learned something today. Okay, so now that we have a picture of the data that we're using, I just want to talk briefly about the technologies that we're going to use to build our pipeline and solve our problem. We could probably spend multiple webinars talking about the ins and outs of Spark or Kafka, but for the sake of time, let's just briefly touch on some key points. So Spark is the heir apparent, if you will, to MapReduce. And MapReduce is a programming paradigm for working with data that's residing in a distributed system. First, you have to write a mapper program, the results of which are then written to disk. And then you write a separate reducer program that might do something like aggregate the output of the mapper program and then again writes that back out to disk. Now, this requirement to read and write from disk is slow. It also requires the programmer to think inside of this MapReduce paradigm, which can be challenging. And I have to say that I have yet to hear someone tell me that they had fun writing MapReduce code. So then along comes Spark with a novel idea. Why not skip the step of writing to disk and simply distribute the dataset in memory? And that is exactly the idea of the RDD, the Resilient Distributed Dataset. And you'll see us working with that when we go through the script. But eliminating the need for disk input and output shortens the execution time for your operations, and it also shortens the overall development cycle because the Spark API is easier to work with. So I think that this is primarily what's responsible for the popularity and rapid development of Spark. Now let's just talk a little bit about Apache Kafka briefly. It's a messaging service that has become increasingly popular due to its ease of use and scalability. Like I said, I'm not going to go into too much detail here because this is really a Spark-centric demo, but I just want everyone to note that Kafka subscribes to and publishes streams of messages. It can store them in a fault-tolerant way, so if you were to lose your stream, you'd be able to pick up where you left off. And it can also do a little bit of light processing itself, which you'll see as we do the demo. Okay, so very simply, what's our solution architecture? Well, we have our data source, that's Wikipedia in this case. We have our messaging service, which is Apache Kafka, where it's going to ingest the data and parse it out into different topics. Then Spark Streaming is going to connect to Kafka and transform the data. We're going to score it using a model that we've built, and then we're going to write that out to an external database in the form of, in this case, it's PostgreSQL, which is also an open source database. Okay, I should make a note though that the connection between Wikipedia and Kafka is done by an open source project called Hello Kafka Streams, and there will be a link to that and the resources at the end of the presentation. So keeping with the theme of this presentation, I want to make the point that the particular data source and where it finally ends up are fungible. Spark Streaming can ingest from a number of different sources, and that data can then be pushed to many different places. One thing to keep in mind about Spark Streaming is that it's not truly real-time streaming. Data is ingested in microbatches. So in this demo, I use an interval of 2 seconds, but you can go down to half a second depending upon your use case. And many use cases are within the half-second to 2-second span of time. It doesn't always have to be near instantaneous ingestion and processing. Okay, so and we've already mentioned some of the use cases, so I won't go into those here. Okay, so far we've talked about why I wanted to do this, the problem statement that we're going to be working on, and we talked about the architecture, and now it's time to actually go into the console and start launching some of these services. So this is Kafka installed on my local machine. Everything you're about to see here is running on my local machine. The code and resources for this are in GitHub. Again, there'll be a link for that at the end. But let's get started. So one of the services that you need to launch in order for Kafka to work is Zookeeper. That's something that it's dependent upon. So what we're going to do here is we're going to start the Zookeeper server. Okay, and some of these are going to take a couple seconds to get running, but you'll see the data coming in shortly. After we start the Zookeeper server and that's up and running, we need to start. Then we can start Kafka. So now I've started the Kafka server, and now that the Kafka server is running, I can set up that connection between Kafka and Wikipedia with the Hello Kafka Streams project. So what this is going to do is going to get that data that's coming from Wikipedia and parse it into a couple different topics. It's going to parse it into a raw topic, which just is essentially a dump of what's being gathered from Wikipedia, and it's also going to parse it into, publish it into a parsed topic, which is a little bit more cleaned up from the raw. So we're going to actually be working with the parsed topic when we get into our script. So what you should see here once the connection is made is a little bit of that internal processing that Kafka can do itself. Namely, you're going to see a running count of number of edits for each user. So there we go. We've connected to Wikipedia and we have our data coming in and a running count of the number of edits for each user. Anna, can you see this okay? Do I need to zoom in anymore?
It looks perfect.
Okay, great. So one thing I want to point out here before I go on any further is that some of the names of users actually have bot inside of them. And if you'll notice, they have generally far more edits than the other users around them. And this makes sense. A bot can do many more edits than a human can. So this is something that we might want to incorporate into our model when we go forward. Okay, so now we have our connection to Wikipedia. Let's take a look at the parsed JSON that I showed you before as it's coming in. Okay, so this is going to launch a Kafka console consumer, and it's subscribing. You see here, it's subscribing to the Wikipedia parsed topic. Okay, here we go.
Rafi, we have a question.
Okay.
The question is this live from Wikipedia?
Yes. Yeah. Yeah, I was looking for a dynamic data source, a dynamic streaming data source when I set about doing this project, and it was surprisingly hard to find something just available on the internet. But this was one that I thought was interesting and could be promising. And then when I saw the isbot edit field, I thought that would be a fun thing to try and work with. But yes, this is being published, I believe, as it happens. Okay. So now we have our JSON coming in. We have our connection. Our next step is actually to launch our Spark program. So what I'm going to do here is I'm gonna walk through this Spark submit statement here and what's inside of this, and then I'm going to let it run just to show you the output briefly. Before digging into the output too much, we'll go and look at the script that I wrote that processes all the data, and then we can actually see how the Spark API is used, do that deep dive that we talked about, and then we'll come back and look at the output again and sort of with a better understanding of what we're looking at. Okay. So what this is saying here is that we're going to submit this script to Spark, and we're going to use 3 cores on my local machine to do the parallelized processing in Spark, and we also have to specify some dependencies necessary for the script to work. So we're going to specify the Kafka Spark streaming connection dependency. We're also going to specify the driver for the open source database that the data is going to be landing in, and that's for Postgres. And lastly, we have to tell Spark the path to the script that it's going to be using, which in this case is direct Kafka pipeline 2.0, and this is a Python script. And we also have to pass a couple arguments to the command line that the Python script is going to look for, namely where Kafka is located, which host and port it's located, and also which topic to subscribe to, which you see here is Wikipedia parsed. Okay, now, but before I launch this, there's actually, you know what? No, let's launch it. Let's see what happens when we launch this. Okay, so this first table that comes up is a historical table of user counts that I have pulled from running the Wikipedia streams for a couple days, and then saving that to a CSV, the counts of the number of edits. And the reason I put this up here at the beginning is to show how you can incorporate data at rest with data at motion. This is only going to show up one time in the streaming program, and then everything after this is going to be micro batches that are coming in. So let's just going to scroll down here to the bottom, and we'll see it coming in. I know this is difficult to read, but I just want you to see the data is coming in and being processed in Spark. It might actually be helpful to zoom out a little bit to see this better, but okay. So that's enough of that. You can see that my program is running and it's ingesting all the data that we were looking at from Wikipedia. Now let's go actually take a look at the script and walk through some of the steps and get a better idea of what's happening here. Okay, so this script is essentially broken up into three parts. The first part is importing the necessary libraries and defining the various Spark contexts that are required to use the different components of the Spark API. Then the second part is declaring different variables and loading the data that we have in a flat file to be joined with data in the stream, as well as any models that we've built offline and we want to incorporate. And then the third step, the most important step I would say, is the actually defining what it is we want to do with the JSON that's coming in. Okay? All right. I'm not going to walk through every single line of code, but I'm going to try to just highlight it. Like I said, just try to highlight the things that I think are most important. So one of the things that you would want to do is you want to define the various Spark contexts that you're going to be using. And obviously the primary one is SC, the Spark context. And then if you're going to create a streaming application, you're going to have to define a streaming context, and which uses your base Spark context. And then this right here is where you specify the interval, the batch interval, whether you want it to be 1 second, 2 seconds, half a second, or more. And then to access the features of the Spark API, such as SparkSQL and DataFrames and things like that, you want to create a SQL context. And this is something I'm happy to share with you all. When I first started working on this, it was very difficult to see the output of my program because Spark was just printing out like endless messages that were not warnings, were not errors, or anything like that. It was just letting me know about what was going on under the hood with Spark. So you can actually set the log level to only print out errors or only print out warnings, and I found that to be very helpful when if you want to debug your program or just see what's going on with your output. Okay, so now we've defined our context. Let's go on to talk about some of the variables that I declare before processing the data. So first, I have my credentials for the external database that I'm going to be writing to. And then any tables that I want to access in that database, I'll define them ahead of time. then this is the table that I had shown you before, the table of historical user counts. I can read the CSV from my local machine, and that automatically parses it with the schema into a data frame. Okay. Finally, I have two models that I use in this pipeline. One is principal components analysis, and the other is random forest. And you may be wondering why I would use principal components analysis. Largely because a teammate suggested that I throw it in there, and I thought, okay, why not? But more seriously, because it's a common tool that's used for data that you don't necessarily understand the importance of different variables. So I figured it would be possibly helpful to some to show how you can incorporate that into your pipeline as well. Okay, so now let's keep going. Onto the most important part of the script here. We're going to actually connect to Kafka, and we're going to start working with that data that we get. So this variable here, KVS, this connects to the Kafka stream, and it looks for those command line arguments that I had mentioned before, the port and host, and the topic to subscribe to. Okay, and then the data that's coming in through that connection, we're going to store that in the variable lines. Okay. Now this process method here, this you can think of as everything that you want to do to the RDD that just came in your microbatch, that little chunk of JSON that just came in, everything that you want to do to that is going to take place inside the process method. Okay, and then once you've defined the process method, I'll go back up in a second. Once you've defined the process method, the way that you use this is that you say, you take your batch, your little batch of data that you just got from Kafka, and you say for each RDD that is going to be in lines, use the process method. Okay, and then you start the streaming application. All right, so now let's look at what we actually did with that RDD. Okay. As I go through this, my main objective here is to show how you can use the Spark API to accomplish a wide variety of tasks. Namely, when you're doing data science work, it itself is a type of pipeline, meaning that once you have your data, you usually have to clean it up. Then you do some feature engineering. You're going to create new fields. You're going to create new variables based on the ones that you have. Then you might have to change around some of the data types in your data sets. And then finally, you progress to modeling and scoring the data, and then you write it out to some place, right? That all occurs within just a normal data science pipeline, let alone a larger pipeline, like a streaming pipeline from data source all the way to final database. So there's different ways that you can accomplish that in Spark. You can use SparkSQL. You can use Lambda functions, and yeah. And so let's go into that. Let's go into that. So here is our first step here is that when we get that JSON in the RDD in lines, we can convert that into a data frame very simply by calling SQL context read JSON, and it'll automatically infer the schema from the JSON and put that into a data frame for you. Then if you want to start using SparkSQL, you simply create a temporary table, and then you can run standard SQL queries off of that. So if you take your edits RDD and you call create or replace temporary view, you give it a table name, then you can start to use SQL like you would otherwise. And you'll see example below. Okay. One thing I wanted to do was write out the raw data before I change anything, before I do any transformations on it. So that is also pretty easy to do here in Spark. So you take your table.
There's a comment you may want to discuss. So the comment is, using an Uber for each RDD is kind of drastic. Gives the wrong idea to people. The dstream API offers quite some functionality on its own.
So can you say that one more time?
Using an Uber for each RDD is kind of drastic. Gives the wrong idea to people as well.
An Uber?
Uber for each RDD.
Okay, I'm not sure what an Uber is in this context, but I'm happy to say that, please, I'm more than welcome to accept, more than happy to accept criticism on my script here, and if people have comments that will help me improve this or be a better programmer, then for sure I would love to hear those. But I don't really understand that particular one. Also, I do want to make a note that when I was writing this, it wasn't my chief goal to do this in the most elegant and succinct way. Rather, it was to try to demonstrate different ways of accomplishing the same thing and showing how you can do that within the Spark API.
We can probably follow up with him, after the webinar and see exactly what the comment was.
Yeah. I mean, I'm always looking to learn, so I would love to hear your thoughts. Okay, so anyway, so I wanted to write the raw data out to an external database before I do any transformations on it, and you can see that here with taking the edits data frame and writing it using a JDBC connection to the variables that we had defined before. Okay, now one of the things now we're going to go into some of the transformations that you might want to do. So if you wanted to add a column, let's say I want to take the byte differential column and I want to just create a binary classification of whether the edit was an addition or deletion. So I take my edits data frame and I'm going to give it a new column, addition or deletion, which is defined by whether the edits data frame, whether the byte differential field is greater than 0. And I'm going to cast that as an integer. That's going to give it a 1 or a 0, whether or not, depending upon the value of byte differential. And we'll store that in a new data frame called transform edits df. Okay. And the same thing here. I'm going to convert different data fields in the data frame to Boolean types instead of strings. So, for example, the type field, I'm going to cast it as a Boolean as well. And then we can update our temporary table that we created before with these transformations. Okay, so now this piece right here, I wanted to show you how you could use SQL in more than just a select star from manner, how you can actually use SparkSQL itself to create different to transform and create different features in your data set. So here what we're going to do is we're going to filter out some fields that we don't want, like diff URL, and we'll cast some different columns as Boolean types, like I mentioned before, and then we'll create 2 new fields by getting the magnitude of the edit and the length of the summary. Okay, and again, the point here is more so to demonstrate the functionality of the Spark API than to necessarily get the best possible answer to our question. While it would be nice to have the best possible answer to the question, since this demo is for enablement, that's my primary goal, and that's what I'm trying to capture here. Okay, so as we're going through here in this script, I have a number of show statements, filtered edits dataframe.show, and that's going to print the data frame to the console, so that we can, in the hopes that when we go back and look at it later, you'll see how these changes are all taking place in the console. Now this line right here, line 182, is going to join the historical edits table that we loaded from the CSV into each RDD that's coming in the stream by the user. And if we've never seen this user before, then we'll just assign them a 1. If we've never seen them before, joining is going to create a missing value, but we'll just assign them a 1 because we've seen them at least one time. We just haven't seen them up until now. Okay, so now we've created a data frame that we can actually use in modeling, and that is filtered for any rows that we don't want, for any columns we don't want, and we've converted our data types to the proper format. So let's show that, and then we'll go on to the actual modeling component. So in order to use principal components analysis and random forest in Spark, you have to take all the features that you want to be modeled, and you have to convert them into a vector. And you'll see what this looks like when we go back to the console. That's essentially what these next chunks are doing here. We're taking the columns in our data frame, and we're creating a new column that is a feature vector. Okay. Another point that I wanted to make here, I wanted to show, is that you can interweave Lambda functions with SparkSQL and using the Spark Core API. So for example, if I wanted to convert the rows I have to convert the rows in the model RDD to label point in order that the random forest function can accept them. So that's what I do here in line 211. Okay. Once the RDD is in that format, in the label point format, I can then use the random forest model that I created offline and pass this incoming batch of streaming data to the random forest model and get my predictions. Okay, and this will all be clear when we see it back in the console. Okay, and then approaching the end here, what we want to have in our final output is a data frame that contains both our original data, the user and the summary and the data that we got from Wikipedia, as well as our predictions of whether or not it was a bot edit or not. But in order to do that in Spark, and this is one of the things that I learned along the way, in order to do that in Spark, you have to create an index that which you can join. And because the data is distributed, if you try to just tell Spark to join two different tables to each other, if there's no index, there's no way to know where the joins should take place because the data is distributed. So that's what we do here. We create an index both on the original data frame and on the predictions data frame, and then we can join them together. Okay, one last point about syntax, and then we'll go take a look at the console again. So what happened after I joined these two tables back by index was that I had two columns, and one of them was the column was itself a data frame with nested columns inside of it. So in order to access subcolumns in a nested data frame, you can simply use dot syntax. So if my parent column that has all of the original columns in it is called calls, and I want to just get the user, so then I do calls.user, and so on and so forth to access the subcolumns in that data frame. Okay, and then the last thing that we do, now we have our final data frame, is we'll write that out to Postgres as well. Okay, so that's the script. Now we can go back here and actually take a look at that as it's happening. I'm just going to zoom out a little bit. Okay. Okay, so since we've been talking, we're up to microbatch number 237 since we launched the process. And we have 12 steps here. First step is, let's look at the schema that we get from the incoming JSON. That tells us our fields and our types. And this is what if you converted this to a data frame, this is what you would see. That's step 2. Okay, now we're going to do some transformations. I'm going to, even though it might be getting small, I'm going to try to zoom out so we can see. There we go. Okay. So when we did our transformations, we added a new field, addition or deletion, and we changed the type column to Boolean. Then we filtered out the differential URL, and we changed the other columns like is unpatrolled, is new, is minor. We changed all those into Boolean types as well. Then the next step we took was we joined our CSV, that was our data at rest, with the data in motion based on just so we could get the historical number of edits, which we thought would be an important feature in the model based on the fact that bots tend to have more edits. So we incorporate that in step 5. And step 6 is where we're starting to work towards the modeling data frame. And this is what I was talking about with creating a features, a column of vectors of all the features that you want to have modeled in relationship to your target variable. So you see here in step 6, this last column here, features. Then now that we have the features vector, or the features column, I should say, you can pass that to principal components analysis, and that gives you your dimensions over here, reduces the dimensions of your data set, and then we can get then we can pass that to random forest, get our predicted values, and compare that to our actual values. I print out the test error, which in this case is a sterling, 100% correct. And afterwards, we create the index by which we can join our predictions back onto our original data frame.
Rafi?
Yeah.
I have a question. Can you real quick go back to the code that writes to the database?
Yeah. Right here. This is I write twice in this. I write to, I think at least twice, possibly 3 times. But I write the raw data out, and then I write the predictions and joined with the original, with the cleaned up data at the end. Is there a specific question about this?
No, just wanted to go back to the code. I guess, he probably missed something, so thank you.
Yeah, sure, no problem.
Yeah, he's fine.
Okay, cool. So this is the final data frame that then gets written out to Postgres. And now what I want to do, and then this whole process starts again the next 2 seconds. So now let's go back. Let's just, before we go on to Postgres, let's just take a look and see, how this is happening in every 2 seconds. So I hope that now that we've gone through the script and seen the API and the various things we're able to do, now that hopefully this is a little bit more informative, showing this, how this is actually ingesting the data and using all those powerful components of the API, like SparkSQL and the machine learning components, going from RDD to DataFrame and writing it out and all that. Well, let's just test to make sure that the writing it out is actually happening. So I'm going to go into Postgres on my computer here, and let's take a look at pretty sure that's the name of the database. Nope. There. Oh, I always forget the from. Okay, so as of right now, we have 382,799. in the uh, raw data, and we have 138,213 in the scored data. That's how many rows we have. So now let's wait a couple seconds. 1, 2, 3, 4. Okay. Now let's see how many we have in Wiki parsed. So we got about 32 more rows there. And in the scored data, well, we got another 10 there. Okay. So hopefully you can. So now we've closed the loop here. We got the final piece of our pipeline running. You can see that we've ingested data from. Well, actually, let me go back to the slide here. So you can see that we were able to connect to our data source from Wikipedia. We brought that into Kafka. We showed everything that was coming into Kafka. Then we connected to that parsed, the Wikipedia parsed topic from Kafka in Spark, and we did a whole bunch of transformations on that data to get it ready for machine learning in the modeling segment. And then we also wrote that out in two different tables in our Postgres database. Okay, so that's it for the demo section of this webinar. Now I just want to talk a little bit about IBM and Spark, and then we'll conclude. So IBM is heavily investing in open source and has been for some time. There's a number of things to talk about. One is the Spark Technology Center in San Francisco, which is essentially a large engineering organization that is dedicated toward making Spark as good as it can possibly be. IBM has also just contributed its machine learning code in SystemML to the Spark project, and Databricks, the inventors of Spark, is a strategic partner with IBM. In fact, outside of Databricks, IBM is has the greatest number of committers and contributions to the Spark project. In terms of education, IBM has Big Data University, which has free courses online that you can go to and learn about how to use Spark and Hadoop and other scalable open source projects, as well as doing events like this. Like my team puts on webinars like this. We have proof of technology events where we do hands-on workshops all day long around the country, and perhaps also importantly, and we'll touch on this again in a second, that a lot of IBM services actually use Spark to support the scalability that's necessary to serve our customers. Okay, the purpose of this slide is to show you how, in my opinion, the Spark API is becoming more and more familiar and user-friendly for people who may have more of a data science or SQL kind of background, like an R or Python, as opposed to a pure developer, a Java developer, a Scala developer, something like that. So I think as time goes on, we're moving away from mapping and Lambda functions to DataFrames and thinking about things in that kind of a way. So as I mentioned before, Spark is, across many of IBM's offerings and internal services as well. The one I highlighted here, the data science experience, is something I encourage you all to go check out because it's free for 30 days. It comes with Spark built into it, and you also get 5 gigabytes of object storage for free as well when you sign up. So if you want to start playing around with Spark, if you're not already, or if you just want to have, if you want to see what a data science IDE looks like from IBM's point of view, then I highly recommend checking out the data science experience. There's features for continuing to learn, and you could search for articles and data sets and things like that if you want to start a new project. And yeah, I definitely enjoy working in it myself. Okay, so if you have any questions for me, obviously I think we have some time to answer them now, but feel free to email me You can always tweet at me. And all of these assets are available on GitHub. Everything I did is it's open source. It's all on my local machine. So you should be able to reproduce this at home and play around with it. Please let me know if you find some interesting stuff. I would love to see that. And these are the Kafka and Spark project homepages. And then finally, the GitHub and blog associated with the Hello World, the Hello Kafka Streams project. That was essential to making this work. Okay, so just to finish, I hope that the Spark API seems to be as easy as pie, and I don't know if I would go that far, but I would say that once I started working with it, it became very intuitive very quickly, and becomes like a pleasure to work with. And it's easy to lose sight of the fact that you're actually controlling, depending upon the cluster you're working on, you could be controlling hundreds and hundreds of machines, but it feels as though you're only working on your local machine. And I think that was sort of a large goal of the Spark project, and if they haven't already accomplished that goal, they're rapidly approaching that. So yeah, that pretty much concludes what I have prepared for you all today. Thank you very much for your time and participating in this. And I guess if you guys have any questions, then I'd be happy to take them now.
Yes, there's a few questions, Rafi. So the first one is, does the GitHub page also include a Docker container with Spark and Kafka already set up?
No, there's no container. However, I provide links to where you can download Spark and Kafka, and depending on your machine, you'll have to follow the documentation to install those. However, I will say that I found them to be relatively easy to install, and I am not a I come from a more just analyzing tables, like analyzing data sets, data science background. Connecting these different systems together was a very valuable learning experience for me. So I think if I can do it, I think you guys can do it too.
Okay, next question. What tool do you recommend using for writing the Spark script? Are you using Jupyter or Zeppelin?
Good question. So I'm using Sublime Text. I think it's really good. I think it's just someone recommended this to me, and I started using it, and I think it's fantastic. You can you basically start typing, and then you come over here and this is free. This is free. So you come over here, you click on View in the menu bar, and come down to Syntax, and whatever, almost any language you want, it'll just change the highlighting of the code and things like that, so that increases the legibility. And then to save, obviously, you just use shortcuts and things like that. I find it to be very, very legible, very clear. And I also particularly enjoy this little on the right here, how you have your whole script kind of laid out on the right, and you can see where you're at in it. I don't know if you guys can see that here. Yeah. So I'm very happy with the Sublime script. I've never had a moment where or Sublime Text, and I've never had a moment where I'm like, oh man, I wish I had something else. It's been really great.
Okay. What is the best way to play with this on our own, either locally or in the cloud?
That's a good question. I think it's easier to start off locally, but if you wanted to do it in the cloud, you would only have to change a couple things. You really would just be, the two parts that would be in the cloud would be your Postgres server, which you can actually provision from IBM on Bluemix, bluemix.net, and then there is a service called Compose, which actually has a whole host of open source databases that IBM manages for you. So that's one place to look on the cloud if you wanted to have your database be in the cloud, would be IBM Compose. And then the Spark instance, when you submit your script to Spark, you would just specify the host and port of you would have to specify where the Spark service is located, and then it should execute in the same fashion. But to answer your question succinctly, it's probably a little bit easier to do it locally.
Okay. Being very new to open source, could you suggest some good online courses to hit the ground running with both Spark and Kafka?
Sure. That depends upon your level of prior experience. I personally find that the Spark documentation is fantastic. It's like the best that I've seen. The Kafka documentation is good as well, but I don't think there's as many people working on Kafka, so it's not quite as good as Spark. As far as places to learn about it, I think Big Data University is a good one from IBM. I think that YouTube is a good resource. And Big Data University, the courses should be free. I think YouTube is good. I think the best way to learn and the way that I learn best is by trying to do something, like trying to do a project, and then when you run into problems, you wind up having to look up, you wind up Googling for specific questions, and sort of over time you like piece it all together. That I find that's the way that I learn the most. If I just go and read the documentation for Spark Streaming, that's not going to be anywhere near as good as trying to build a simple Spark Streaming application myself, trying to solve some problem myself. So that's what I would say. I would say go check out Big Data University. Get good at Googling and surfing YouTube, and then also pick something and then really try to build it. And it'll be really hard. You'll run into lots of problems, but if you persist, you will come out on the other side knowing a ton.
Okay. Do you know of any freely available streaming IoT data on the internet?
Great question. I was looking for that myself. I really wanted IoT data. That was my first attempt. I didn't really find anything great. One of my colleagues told me that there's a site called nextbus.com or something like that publishes like buses, schedules, and whether they're on time or not. And I mean, that's not quite IoT, but it's close because I think they keep track of where the buses are using some sort of IoT device. That was the best thing that I found. One thing you can do though is you can buy fairly inexpensive IoT devices, and you can get creative with it and start recording the data with it and things like that. And I bet you if you just spend some time thinking about how you could use one of those, you could probably come up with a cool project.
Okay. What is IBM's view of structured streaming?
Oh, nice. So structured streaming is for those of you who don't know, structured streaming is a new component to Spark, and obviously Spark Streaming, that instead of relying heavily on the RDD based way of programming in Spark and working with data, it tries to move even the streaming component towards DataFrames. And as far as IBM's view, I mean, I think that it's a good development. I think that anything that helps data scientists and developers implement their vision and solve problems in a more efficient way, I mean, I think that's a good thing. So myself, for me, it's more intuitive to work with a table than to work with a RDD. So if streaming moves toward in that direction, I think that's a good thing.
Okay. I'm curious what the overall error rate of the prediction was.
Yeah, that's a good question. So it was not great. There were times that it worked well, but I think that it was not as substantial. It wasn't a great model at all. That being said, it was kind of like the first attempt at modeling the data, and the data is kind of strange. It's not totally well documented what all those fields mean in the first place. So I think that more work needs to be done to have that model actually be better. My colleague suggested a good idea though that would not be hard to implement at all, which is basically if the username contains the word bot in it, then that's probably a pretty good indicator that it's a bot. But yeah, there were times though that it did pick up on not so obvious cases. Correctly pick up on it. I hope that answers your question.
Okay, and last question. This is very interesting to learn, but to get hands-on required to install lots of software and packages. This is more a comment than a question.
Can you just say it one more time?
This is very interesting to learn, but to get hands-on requires lots of software and packages, requires the installation of lots of software and packages.
Yeah, it's true, and that's something that I learned about this subject when I was doing this project, and maybe this is a good way to conclude, and that is that when you're talking about a pipeline, what's the scope of your pipeline? Are you talking about I have a table in front of me, I have a CSV, and I'm gonna have that be the ingestion of that is my starting point, and the output of some model or something is the endpoint, and all the steps in between, that's my pipeline, right? That's like typical data science kind of work. But this project really showed me how in order to have a streaming pipeline, you need to be able to connect different systems to each other. And that has nothing to do with tables anymore. You're not really working on the data, you're working on connecting the data, to different systems. And that's its own skill. So that's something I learned doing this project, and yeah, so you do have to install, different libraries and different packages and things like that. But once you do that, though, it's a very you'll grow a lot from it. You'll grow a lot from it, I think. So yeah.
Okay.
Those are my thoughts.
Thank you so much. Thank you everyone for joining us, and thank you so much, Rafi. We will send an email with a link to the recording for the webinar, and we'll include the slides so that you have all the links that Rafi mentioned during the presentation.
Yeah, thank you very much, everyone. And if the person who had the question in the middle is still there, please reach out to me. I'd love to understand what you were pointing out. All right, thank you very much, everybody.